you're going to be learning how to take derivatives of exponential functions with base e. So by the end of the lesson or this video, you'll be able to compute derivatives of exponential functions that have base e. So before we start, let's go ahead and just recall some properties of exponential properties. So if you have an an times an a to the n, that is an plus n, a to the n plus n. For division, if you have an a to the m divided by a to the n, that is a to the m minus n. And for exponentials that are being raised to another power, an additional power on top of that, then you simply just multiply those. And just to better illustrate what's actually going on with these properties, I'm going to go ahead and just use x squared and x to the third. Well, you have two x's and three x's, and the total amount of x's that you're dealing with here are 5. So if you multiply x to the third times x to the times x squared, you can just essentially just add the exponents and you have x to the 5th. Similarly for division. So again, just to illustrate what I'm trying to explain over here, is that if you have 3 x's on top, 2 x's in the bottom, you pretty much only have 1 x on top, which is the same thing as 3 minus 2 power, and that is x to the first power, and x to the first power is really just x. Now for this one, I'm going to say x squared raised to the third. Well, what does a power of 3 mean? Power of 3 tells you that you have 3 times the number in the inside that you're raising the power of. So that'd be the same thing as x squared, x squared, x squared. Well, you're dealing with 6 total amount of x's, and that is x to the 6. So just multiplying the exponents will get you this right here. And the second part of the do now is that now you're dealing with e, and e is a number, kind of like pi. E is 2.71828 ... It's a special number. So it's the same thing, because a can be any number that's not 0. So you can go ahead and use e, and the properties will still hold. Okay, now to get down to the derivative. So theorem 5.11 says that let u be a differentiable function of x. The derivative of e to the x is e to the x. And that's it. E to the x is the only function whose derivative is equal to itself. So that'll probably be the easiest derivative rule you'll ever have to remember. Now to go on with the second rule. So the second rule is very similar to the first rule, except that now u is a differentiable function. So u is a function of x. U can be any function. It could be 2x. It could be, I don't know, x squared plus 2x plus 1. It could be even a trigonometric function, as long as it's a function and is differentiable. You can use the second rule. So you may already know the gist of this. So it's going to be e to the u, and then times the chain rule, whatever u is, u prime. So let me go ahead and just show you a pretty cool proof. It's a quick proof. It's not a very rigorous proof. It's a quick proof for number 1. I want to show you that the derivative of e to the x is e to the x itself. So let's just say that you have y is equal to e to the x. And let's say that I want to rewrite this equation different. So I'm going to go ahead and take the natural log of both sides. That is natural log y equals natural log e to the x, according to the power rule for logarithmic functions. I can drop the x to the front. Natural log y is equal to x, ln of e. Now, ln of e is equal to 1. That's just a property. So this is actually just 1. So rewriting the last equation, natural log y is equal to 1. Now let's go ahead and differentiate this, assuming that you don't know what the derivative of e to the x is, but you do know what the derivative of natural log is. So let's go ahead and differentiate both sides with respect to x. Well, what's a derivative? Well, that's a mistake right there. I'm sorry. That's supposed to be an x. That's supposed to be an x. I'm sorry. So I got it confused with this right here. So this x remains the same because 1 times x is x. So that's my fault. So let's go ahead and differentiate. What is the derivative of x? Well, the derivative of x is 1. What's the derivative of natural log y? Well, according to the previous video, it's 1 over y times the derivative of y, which we don't know. We don't know what y is. The derivative of y is. You'll know what that is in a few days from now. So I'm just going to write it as derivative of y. According to the chain rule, it's 1 over u times the u prime, and the derivative of y is some derivative that we're going to figure out right now in a bit. So notice that I have 1 over y times the derivative equals 1. I'm going to remove this y by multiplying y to both sides. So I'm almost done with the mini proof here. So I have the derivative of y is equal to y. Well, what is y in the beginning of the proof? Y, I had said, was e to the x. So rewriting y, the derivative of e to the x is e to the x. And that's the proof for number 1. So something pretty cool that I'll be sharing with you guys. I'll be sharing with you guys some proofs that may seem appropriate in calculus, but not all proofs. So let's go ahead and talk about the derivatives for the following examples. So find the derivative for the following exponential functions. The derivative of e to the 2x minus 1. According to the derivative rule, e to the u times u prime. I'm going to do like the previous video. Label your u. What's the derivative of u? It's 2. So the derivative of e to the 2x minus 1 is e to the 2x minus 1 times 2. And you're done. Next one. We're going to take the derivative of y equals e to the 3x squared. Again, u is 3x squared. So u prime is 6x. Now, the derivative of y is going to be the rule, this rule. So it's going to be e to the 3x squared times 6x. Now, you could write it like this if you'd like to. On free response, it doesn't matter. but I'm pretty sure in multiple choice problems you'll probably see it like this. The next one is going to be slightly more difficult because now u is negative 3 over x, which can be rewritten as negative 3 over x to the negative first. So the derivative of this, using power rule, you drop the negative 1. Negative 1 times negative 3x to the negative second, which is positive 3x to the negative second, which can finally be rewritten as 3 over x squared. Now, that was a lot. So I did mention that this is going to be a tricky rule. So this is my u, and this is my u prime. So the hardest part is just find the derivatives. It's not the derivative of e to the u that's the hardest, it's the derivative of the u's. So my final answer for this, the derivative of e to the negative 3 over x, I'm just copying the problem, is e to the negative 3 over x times 3 over x squared. For this problem, we're going to be using yesterday's lesson, actually, the previous video. This is actually a natural log derivative rule. So recall that the derivative of ln u is 1 over u times u prime. However, the inside, the u, contains an e. So we're going to use what we just learned today here. So let u equal, or I'm sorry, u is equal to e to the 3x. U prime is 3 e to the 3x by the derivative rule for e to the u. So, according to the previous video, the derivative of ln u is 1 over u prime, and I already have my components right here. 1 over u times u prime. You could rewrite it. Just don't do this. Do not cancel. If 4 had an e to the 3x, then you could do a common factor and then reduce, divide out. But since you don't have common factors, you cannot do that. Okay, let's go ahead and do our final example for this page. So this problem, you could do it using the ln rule, the derivative of ln u. You could do that. But I do know that e has a power of x to the third. So that means that if I go back to my log property rule for powers, that can just go to the front right there. So this is just a rewrite. This is not a derivative rule. I'm just rewriting. Recall that ln e is equal to 1. So y is really just x cubed. And the derivative of y is 3x squared. Now we're going to get to some problems that are going to be a little more difficult, because now we're not just talking about derivatives. Now we're going to use the derivatives to find the equation of the line tangent to y, the function, at x equals 1. So before we find the tangent line, we need a slope, which is the derivative, and we need a point. So we have 1, comma, well, I don't know what y is, but if I plug in 1 into here, here, and there, I can figure that out. And that is e plus 2. So I have the point 1 comma e plus 2. So all of this is a y value. I know it looks kind of weird, but that's a y value. If you think about it, e is 2.71, 2, that'd be a total of 4.71, but we're going to write it in exact form. That's exact form right here. So let's go ahead and now find the slope, which is the derivative. dy dx, or you can say y prime, is equal to, well, that's a fraction, which means that we're going to have to use the quotient rule here. So according to the quotient rule, you guys know it as low d high. So low derivative of the high, e to the x times square root of x. That's a product rule, so it's going to be derivative of the first, keep the second, plus the first, now the derivative of the second. You guys are probably wondering, well, what happens to plus 2? Well, plus 2, what's the derivative of plus 2? It's 0, so there's no, you don't have to write plus 0. So this is low d high. Let me go ahead and write that out. Low d high. Now it's going to be high d low. So high is the e to the x square root of x plus 2. D low is 2x. All over the low squared. Well, what is x squared squared? That's x to the 4th. Now, do not clean up. You don't have to clean this up. All we want is the derivative. And we're going to go ahead and plug in 1. So the derivative when x equals 1 is simply just all the x's with 1 plugged in. So that's going to be 1 squared times e to the 1 times square root of 1 plus e to the 1 times 1 over 2 square root of 1 minus e to the 1 square root of 1 plus 2 times 2 times 1 all over 1 to the 4th. That 1 to the 4th is just going to be 1. So really, I'm just going to be dealing with the numerator. So let's clean this up a little bit. So 1 squared times all of this is just going to be all of this. So it's going to be e. The square root of 1 is 1. So e to the 1 is just e. So 1 times e is just e plus e again. And then 1 over square root of 2 times, 1 over 2 times square root of 1 is just 1 over square root of 2 minus, this is going to be e plus 2 times 2 all over, well, we just said that's not necessary, so let's go ahead and distribute this here. So it's going to be e plus e over square root of 2 minus 2e plus 4. And we can go ahead and now distribute the negative. So that's going to be e plus e square root of 2 minus 2e minus 4. Now just combine like terms. E take away 2e is minus e plus e over square root of 2 minus 4. And this is my m. So let's go ahead and clean this up. So this is a derivative. Now all I want to do is write it in its point slope form, which is y minus y1 equals mx minus x1. So let's go ahead and plug in everything that we know. So we know that m is all of this. So it's going to be parentheses negative e plus e over square root of 2 minus 4 x minus x1, and x1 we just said it was 1. Y minus y1 e plus 2. And there's my derivative. And that pretty much completes today's lesson.